Dear students, welcome to another lecture in statistical quality control. So we were seeing about some of the tools that are used for statistical quality control. Now let us see the normal distribution curve. See, you know that this normal distribution curve is a bell-shaped curve like this. We have seen this before also. See, when the frequency distribution that we talked about yesterday, if the number of observations are increased and if only chance causes of variation are present. You see, here we are talking about chance causes. There is some other cause also, like assignable cause. We will see a little later about these two causes. Suppose only chance causes of variation are present in the quality characteristic measured, then the frequency polygon appears as a bell shape and approximates the normal distribution. Okay, so if assignable causes are not there, only chance causes are there, then whatever the quality characteristic may be, that means it can be a diameter, it can be thickness, or it can be anything like that, the quality characteristic that was measured, it approximates the normal distribution curve, this bell-shaped curve. Now the characteristics of normal distribution curve are, it is a bell-shaped and symmetrical about the mean. The center we have the mean, this is the arithmetic mean, here x bar is shown, and it is symmetrical. That means what is how the left hand side is the mirror image of the right hand side. Okay, the curve is fully defined by these two things, x bar, that is the arithmetic mean, and sigma, that is the standard deviation. These two things, if you know, we can completely define the normal distribution curve. Now this is, you can see on the positive side, 1 sigma, 2 sigma, 3 sigma, it goes like that. On the negative side, minus 1 sigma, minus 2, minus 3 sigma. So the normal distribution curve extends, you can say, minus 3 sigma to plus 3 sigma. This with so much it extends. Okay, so norm, and you can see, if you take x bar plus or minus 1 sigma, so how many components fall within this limits is 68.26%. that is given in the table also here. If it is 2 sigma limits, 95.46% components fall within this, and if it is 3 sigma limit, it is 99.73% components fall within this. Okay, so when we select 3 sigma limits, we are 99.73% sure that the observations will lie within these limits. Okay, now the applications of normal distribution curve, or the benefits or significance of normal distribution curve. The frequencies of occurrence of the parts are plotted against their respective classes of sizes. If the curve approximates normal distribution curve, that means no assignable causes of variation are present and only chance causes. Just by looking at the curve, if it is a bell-shaped curve, then you can safely say that there is no assignable causes, only chance causes are there. That way you are able to clearly say, see, it is a good thing. Second, in process capability study, normal distribution curve is used to find whether the process is capable of meeting the specified tolerance or not. You see, when we when a designer gives the design specification, you say, suppose a shaft is to be manufactured with a dimension of 50 plus or minus 0.02 mm. So that is this specification with the tolerances. Okay, so this normal distribution curve is used to find out whether our process means all the machines involved, the materials involved, and workers involved, all those people put together are there in the process. If our process is capable of meeting those specifications, to find out that normal distribution curve is used. Then third one, the area under normal distribution curve between two limits represents the total percentage of production which lie between these limits. That's what we have seen here. This is the area under this curve within 1 sigma limits, within 2 sigma limits, 3 sigma limits. So how much percentage falls within that we can know by the normal distribution curve. Okay, normal distribution curve indicates when we select 3 sigma limits, then we are 99.73% sure that the observations lie within the permissible limits. Then normal distribution curve helps to calculate the expected proportion of observations which will be less than or equal to specified value of x bar, that is the arithmetic mean. And on the next thing they are saying, which will be beyond specified limit x bar. So within x bar, how many are there? Beyond that, how many are there? That also our normal distribution curve will be able to tell. Okay, now let us see the thing called variability. Variability means it is a variation. Variation comes. Variation means one differs from another. One varies from another. Okay. You see, no production process can produce all items exactly alike. It is practically not possible that two products can be alike in all respects. Like no two human beings are exactly alike. Okay, even identical twins, okay, at least their fingerprints and other things are different. Okay, anyway, production process consists of combination of three elements, namely men, materials and machine. These three M's are involved. Each element has some natural variability. This variability cannot be eliminated because it is impossible to identify. For example, if you take the materials, that is the raw materials. Suppose a drilling operation is to be performed on a casting. The raw material used for producing hundreds of castings may have some variability from unit to unit. Some units may be harder than others. Some may have blowholes, some may have some other defects. No, hence, this is the source of first variation. What? Raw material. So raw material, see, like when you make rotis in the house, no two rotis will be exactly alike. Like that. See, when you are kneading the dough, okay, the dough, each lump cannot be the same. There will be some variations. Okay, next, machines. Second variation is, source of variation is machine. See, suppose mass production of parts is done by a number of workers on different machines. Now there are different machines involved here. Okay, the condition of these machines also may differ. Some machines may be in poor conditions, some may be in good conditions, some are improperly maintained. Okay, so the second source of variation is the machine. Now the third Now the third source of variation is man, that is the operator or the worker. See, which is most variable among all. You see, these raw material machines may not be varying some ways, may not be bringing so many variations into the component, into the product, but man brings more variations. So it's the most variable among all. His decisions, actions directly affect the extent of variability more than other sources. Okay, there may be differences among skills of workers doing the same job. Even a person, just within a space of 5 minutes, he is making two products. Even he himself makes, and there will be variations. Okay, because so many factors are involved. There cannot be, he cannot exactly make alike. Some dimensional variation also at least may be there. So there are two types of variations: variations due to assignable causes and variations due to chance causes. Now let us talk about variations due to assignable causes. The variations due to assignable causes possess greater magnitude as compared to variations due to chance causes. See, the magnitude is greater, means the variations that are coming into the component, into the product, because of assignable causes, this variation will be more compared to chance causes. Okay, and they can be easily traced and detected. But the advantage of assignable cause is you can find out what is causing it, and you can trace it, and you can eliminate it also. The variations due to assignable causes may occur due to differences among machines, differences among materials, differences among workers. You see, because of the differences in machines, if it is happening, if you want to eliminate such variations, you can perform on the same machine. Then variations may not be there. Differences among materials, if it is arising, the variations are coming. Then you can take the material from same vendor or same supplier, and from the same lot, you can do. Then you can be able to eliminate. Difference among workers also, to some extent, you may be able to eliminate by asking the same worker to do it. So with the same skill, if the worker is the one person, skill variations won't be there. Okay, so like that, to some extent you can eliminate. Then differences in each of the above factors over time. You see, time also plays a role here, because over time, these things also may bring variations. Then differences in their relationship with each other. Okay, because one worker working with one machine and some other worker working with some other machine or the same machine, these also, their relationships also will bring variations. These variations may cause due to change in working conditions, lack of quality mindedness amongst the workers, and the human errors, even sometimes coming because unintentionally they may be coming. For example, due to continuous use of drill to make holes in various components, the cutting edges of the drill may become blunt and the performance may be dull. So after some time, it will turn to make slightly smaller diameter holes than the specified drill size. You see, this is an assignable cause. You will be able to detect it. Okay. But only that is, they possess greater magnitude compared to chance causes. Now let us talk about the variations due to chance causes or inherent causes. Chance causes are inherent. Inherent means it is, it is present within the machine, or it is present within the process, like that. The inherent in any process or part. Variations due to chance causes are difficult to trace. See, this is the characteristic of such kind of causes. Chance causes are difficult to be traced, whereas assignable causes are easy to trace. Okay, so because it is difficult to trace, you cannot trace, means how will you be able to control? You cannot control. Okay, like that. So these can occur even under best working conditions, and but because these variations may be due to inherent unavoidable characteristics of the process or the machine, which occur randomly. Therefore, they are difficult to be traced and controlled. Now, example of chance causes. You see, a little play between nut and screw arising during life of a machine may lead to a backlash error and may cause a chance variation, change in dimension or variation in dimension of a machined part. And another reason could be power fluctuations also may bring some kind of variations into the system. Okay, so these are the examples. See, if these variations that are arising because of the chance causes, if only these variations are there, then the observations will follow the normal distribution curve. See, the nature of graph plotted by analysis of obtaining readings will approximate normal distribution curve if only chance causes are present and assignable causes are not there. Okay. Now, here in a tabular form, it is put this differentiation. See, on one side we have variation due to assignable causes, and on the right side we have variation due to chance causes. See, the first difference is that means assignable causes. Assignable causes are due to unnatural variation in the elements of production. Unnatural, it is not natural. Okay, that is m cube. M cube means, we are saying material, machine and man. These are the elements of production. These elements of production, in them some unnatural variation is coming, because of which the variations due to assignable causes are coming. Whereas in these chance causes are due to natural variation in the elements of production of M3, that is material, machine and man. Okay, then second difference, they can be easily detected or traced. See, assignable causes are easily detected or traced. They can be identified and analyzed and also eliminated, whereas the chance causes are difficult to trace. From where it came also will not be able to say, because they cannot be identified. These variations occur randomly. It is random. There won't be any pattern. You see, assignable causes, there may be a pattern. The chance causes are random. There is no pattern. So they are accidental in nature. Chance causes are accidental. Okay, then the third variation is they possess greater magnitude. The magnitude of variations now will be more for assignable causes, whereas here it will be less. Okay, you see, there sometimes they may even cancel each other's effects. There, if more than one chance causes are there, they may cancel each other. And they may not also. Okay, now examples. You see, examples of assignable cause variations are differences among these elements of production, that is materials, machine and man, change in working conditions, lack of quality mindedness, these may bring in the variations due to assignable causes. Then example for chance causes variations is a little play between nut and screw may lead backlash error, which may cause variations in dimension of part and for power fluctuations. Two examples are given here. Now let us talk about control charts. These are also tools that are used for statistical quality control. Now, control chart is the most commonly used SQC tool. It is a graphical representation of the information that is collected, the data that is collected, and the data or the information may pertain to measure quality characteristic like length, diameter, thickness, etc., which is measured by precision instruments. Okay, and so now control chart can be said you can say it as a device to specify the state of statistical control, or it is a procedure to attain or achieve statistical control, or as a tool to judge whether a state of statistical control is attained or not. Okay, then now classification of control charts. There are many control charts, so we have to classify them, you have to group them. So control charts can be grouped into two categories on the basis of the type of statistical data collected during the inspection. So one is variable chart, the other is attribute charts. On the basis of a type of statistical data, you can classify it into these two categories, broad categories, variable charts and attributes. So now what are variables, what are attributes, we have seen in the previous lecture. Okay, now variable charts can be defined as the control charts used for analysis of variable data collected during inspection carried out to find the quality characteristic of a component using precision measuring instruments. Now, like we are talking about the diameter, length or thickness and such kind of quality characteristic which is measured using the precision instruments, precision measuring instruments. Then for such things, what charts are used are called as variable charts. These are X bar chart, this is one chart, then an R chart is another chart. These two charts are used for variables. Now attributes charts. See, attribute charts can be defined as control charts used for analysis of attribute data collected during inspection carried out to find conforming and non-conforming products. Conforming or non-conforming products, that is non-defective and defective products respectively, by using go gauge, no go gauge, such things. You see, this is one thing, go gauge, no go gauge, or very any blowholes present, not present, accepted or not accepted, something like that. Cracks are present, not present. See, like that. See, these we have seen on the previous thing. Attributes, the data that you give, it doesn't come in fractions, whereas variable data comes in fractions. So if the data is variable data, then variable charts, X bar chart, R chart. If it is an attribute data, then it is P chart, C chart, NP chart, U chart, etc. So now the classification is broadly as variable control charts and attribute control charts. In variable control charts, you have X bar chart, R chart. Attribute control charts, you have P chart, NP chart, C chart and U chart. Okay. Now, commonly used control charts are briefly explained below. Now, X bar chart. X bar chart is the arithmetic mean or the average of the measurements in the sample. It is known as X bar chart. You see, if you, it shows the centering of the process. Centering means, if the measurements are falling towards the x bar, that is the centering in the center of the limits. Okay, so for that x bar chart is used. R chart, it is a range of measurements in a sample is shown in R chart, and R chart is shows uniformity or consistency of variations. You see, sometimes just because the average it is even if the average values of variations observed in the readings obtained are near to the target value, the process is said to be out of control if the variations in the readings are found to be large. See, just because the average is coming, you cannot accept it. You have to see what is the range of the readings also, because one is falling much to the left of the center, one is falling much to the right of the center, and if you take the average, it may come in the center. So the average chart, just because the readings are coming in the center, you cannot conclude. So your range charts are also required. Okay, then P chart. P stands for percentage of defectives. P chart is percentage of defectives in a sample, is known as P chart. So therefore it is called as defective chart. Then there is something called as C chart. See, the number of defects in the sample is known as C chart. You see, defective is different, defects is different. You see, in one defective part there can be number of defects, like that. Okay, so C chart is used for defects, therefore it is called as defect chart. Now let us see what are the purpose or the merits of control chart. See, the main purpose of the control chart is to find out the deviations of the deviations in the measurement of the any quality characteristic of the product, so that the improvements can be quickly made to correct the process before large quantities of defectives being produced, resulting in wastage. That means what? Control chart gives us advanced warning. You need not produce many parts before detecting. In a few parts, the moment you start producing, you take the data and plot the charts, you will come to know whether the process is in control or out of control. Okay, so thereby you will be able to take corrective action and wastages are avoided. Then there are other important purposes also, like to determine whether the given production process can meet the existing specifications without a fundamental change in production process. Is it given design specifications, whether our process will be able to meet or not? To determine that, control charts are used. And to indicate whether the process is in control or out of control, you can use the control charts. Then determine the process variability and to detect unusual variations, that means because of the assignable causes which are coming, you can use the control charts. Then to provide information regarding selection of production process and setting of tolerance limits, for this also you can use the control chart. Then to secure information to be used in establishing or changing the production process, if you want to continue with the process or if you want to change the process, for that, if you want to get information, you can use process charts, control charts. and to provide a basis for current decision on acceptance or rejection of manufactured or purchased products. That is the so to provide the basis for acceptance and rejection of the product, also control charts are used. Quality characteristic can be measured as well as expressed in numbers. We are putting everything in terms of numbers. Okay, so in the quality chart, the control charts, these are plotting these numbers. Then to give a feedback which can be used for planning and control purposes in future. This is another purpose of control chart. To ensure optimum product quality level, and to find out the rejected lots, whether to find out the rejected lots which need 100% inspection instead of sampling inspection. Sample inspection means few things if you are checking, it is called sampling inspection. If totally 100% if you are checking, that means 100% inspection. So when sampling inspection should be done, when 100% inspection should be done, okay, to determine that also control charts can be used. These are all the different purposes for which control charts can be used. Okay. Then demerits of control charts. See, when there are some advantages, there will be some disadvantages. So what are those disadvantages? See, results of analysis may be affected due to errors in measurement or calculation. You see, this is one thing. If the measurement taken is not taken properly, or if the calculations you are doing are not proper, you see, then the results of the analysis will be affected. But the thing is, now calculations mistakes taking place is almost nil, because the data is fed into the computers, and those are the computers have some software calculations and other things, software which use calculations and other things which are tested again and again. So calculations errors won't be coming unless you do it manually, but the measurement errors can come. But that those also can be eliminated if trained quality inspectors are doing the measurements, then that can be eliminated. Anyway, you see, unless these are done properly, errors may come in. Okay, so we cannot depend that much upon the results of analysis. Then second is, highly skilled and trained labor is required to conclude exact results due to their complexity. You see, now these things are to work as quality inspectors, highly skilled people are required, trained people are required. Okay, but because of the use of computers, some of those things are eliminated, but still even sometimes most of the times, even to run those software, even to debug some problems that are coming in that software, for that also trained people are required. You see, the more trained, more highly skilled people you require means what? You have to pay them more money. You have to spend more money. More money means it is a disadvantage. That's how highly skilled. Why did we don't want highly skilled? Because we have to pay them more salaries. So these are the disadvantages of control charts. Okay, then applications of control charts. Control charts are normally used for so many mechanical engineering components like shafts, spindles, balls, pins, holes, slots, etc. So many machine shops, shop floors, will be manufacturing these things, and those components should be measured using measuring by precision measuring instruments. Then for studying toolware also, control charts are used. Bullets, shells, sieves, sometimes for a defense purposes, like ordnance factories. Some of the ordnance factories, they'll be producing bullets, shells and other things, and which the soldiers and others use. Okay, for such applications control charts are used. Then soldering joints. Nowadays electronics is extensively used, from your mobiles to laptops, computers, everything. These boards are there. Soldering joints are used. So for all this, control charts are used. Then castings. If you have these castings, control charts can be used. Even in textile industry, cloth lengths. I don't know why they have put it in the same line, castings and cloth lengths. Okay, for that also control charts are used. Then defects in a component made up of glass, in glass manufacturing also, whether it is glasses that are used for automobiles, or even mobile screens and other things, all these glasses. For those defects also these control charts can be used. Then final assemblies of components and many more. For all these, control charts are used. These are the different applications of control charts. Okay friends, then today we'll stop here and we'll continue in the next lecture tomorrow. Thank you.